Two nice things about this video. Number one, it's our last video for the week because it's our last slide. Number two, it does not involve graphing. So for those of you who are like not big fans of graphing and want a break, we're going to introduce solving linear equations. And you've seen this in the last couple of slides before you got to this video. A linear equation is an equation that has variables but no exponents. Okay, has variables but no exponents, and that's what we mean by a linear equation. The other thing you'll notice, it only has one variable. I mean, this has x twice, but it doesn't have x and y. It just has x, or just has m, or just has whatever, but it only has one different variable that you may see multiple times, okay? So one different variable only, in this case it's x, and no graphing involved. What we're actually trying to find is we're trying to find the value of x that makes this true. You've seen it before, simple ones like this. You might have seen ones like this, 2x equals 8. And you said, hey, well, we divide by 2, and then 2 divided by 2 is 1x, and x equals 4, right? That was really a little wee linear equation right there, 2x equals 8. So what we're doing is we're going to solve one that's a little more complicated. And then that's going to end our week 6. So here we go. This one's more complicated because it has fractions, right? And one of the approaches I'd like you to see is the same as we did. I want you to get rid of the fractions, because the reality when you're solving a linear equation, whatever you do on one side of the equal sign, as long as you do it on the other side of the equal sign, you maintain this equality. The numbers might not look exactly the same, but you maintain the equality. So what I've done in the slide, and what I'm going to do here is I'm going to look at 2, 9, and 6. I'm going to look at the denominators. Now this denominator we know is 1 as well, but that'll be fine for anything. What's a common denominator of 2, 9, and 6? And when we look at common denominators, that common denominator is going to be 18. Okay? But in this case, we're not going to create a common denominator of 18. We're going to multiply each one of them by 18. And why we do that is this. We'll multiply that one by 18. I'll put it in, and then I'll explain why we do it. Okay. So we're going to multiply this one here, 3 over 2x by 18, and then this one here, 1 over 9. I put the minus out front here, and then this one here, and then I put the plus out front, and this one here. 3 over 1, does not matter, okay? So what we do, okay, 18 times 3. Remember when we're multiplying fractions, this is really 18 over 1, right? So 18 times 3 is 54. So this becomes 54 over 2x. 18 times 1, this is minus 18 over 9, equals 18 times 5 is 90, 90 over 6, and of course there's an x there. And 18 times 3 is, we know there, plus 54, okay? And you're like, well, that didn't help much because now I just have bigger fractions. But the strategy of taking the common denominator and multiplying it out is this. You don't really have fractions. 54 divided by 2 is 27, so 27x minus 18 divided by 9 is 2. 90 divided by 6 is 15x, and plus 54. Okay? So if you multiply by what would be the common denominator and use it as a multiplier, we get, and it'll always work. These will always drop out to be just integer numbers. And then the question is, well, how do I solve that? Well, what I want to do is I want to get the x variables on one side and just the numbers on the other side. So I have 27x here, it looks great. I want 27x, okay? I'd like to have the other x, the other 15x over here, okay? So I'm gonna subtract 15x on this side. You know what, actually, let's do that in red so this looks different. I'm going to subtract 15x on this side because I don't want 15x on this side. But remember we talked about that balance, that equivalency. As long as I subtract 15x on this side, it'll work, okay? So I know I have the negative 2 here still, and I'm going to subtract 15x here, and then over here, well, 15x minus 15x is 0x, is nothing, so I'm just left with 54. Okay. And now if I simplify that, well, on this side I have 27x and minus 15x, and that is 12x. I still have the minus 2 equals 54. And we've run out of space. So just take a little pause. We're going to go up here. Okay. And we're going to continue up top here. Hopefully don't run out of space anymore. Continuing above the red line. So we have this 12x minus 2 equals 54. Now, we don't want the minus 2 over there because we only want x terms over here. We're really trying to get it really simple, okay? Because eventually we'd like it to look like this so that we can just do a little bit of division. That's our goal. And we haven't hit that goal yet, but we will as soon as we get rid of this negative 2. Now, I don't want negative 2 on this side, so if I add 2, I would get rid of it because negative 2 plus 2 is 0. But to do that, I need to add 2 on that side because I have to do it on both sides of the equal sign to maintain balance. So here now 12x minus 2 plus 2 is 12x, and 54 plus 2 is 56. Right? So I have 12x equals 56. But I don't want 12x. Kind of like I didn't want 2x over here. I want 1x. So I'm going to have to divide by 12 on both sides. Again, as long as I do it on both sides, I maintain the balance. 12x divided by 12 is 1x. We don't have to show the 1, we just have x. And 56 divided by 12, that's not a perfect number. It's still going to be a fraction. So the best we can do is reduce that. I'm going to put my x down here a little bit so we don't run into the fractions. The best I can do is reduce that. I'll say, okay, well, I know 2 goes into it. I think 4 goes into it. Both of them. So 4 goes into 56 14 times, and 4 goes into 12 3 times. So our answer is x equals 14 over 3. For those of you who like mixed numerals, we could write it as 4 and 2/3. 4 and 2/3. Okay. So what did we find? Well, we found that if I use 14 over 3 and substitute it in for the x's, I'm going to get the left side equaling the right side. So we found the actual number, 14 over 3, that makes this true. Right? No other value of x will make this true. No other value of x will make 3 over 2x plus 1 over 9 equal to 5 over 6x plus 3. 14 over 3 is the only value. Okay. Let's prove it. Okay. I'm going to get rid of all this. You still need that. Just go back in the video and it'll be back there. But let's prove it. So if I said 3 over 2, and where's my blue here? And I put in 14 over 3, and then I have 1 over 9 equals 5 over 6, and instead of x, I put 14 over 3, right, plus 3. Now let's prove that that's going to work. Well, let's see. 3 over 14, we could cross out, right? We could do that. We'll do it the longer way here. This is 42 over 6 minus 1 over 9. 5 times 14 is 70 over 6 times 3 is 18 plus 3. And since everything else is a fraction, let's make it 3 over 1. Okay. All right, so let's see what we're dealing with here. Let's do a reduction first. 42, well that is 7 over 1 minus 1 over 9 equals, let's see, 35 over 9. Best thing we can do is put 2 in there, plus 3 over 1. Okay, let's see what we got here. Common denominator of 9, so that's 63 over 9 minus 1 over 9 equals 35 over 9 plus 3 over 1, 27 over 9. Okay, I'm out of space, so let's just go to the red and see what we would have. So 63 over 9 minus 1 over 9 is, on this side, 62 over 9. Okay? And on this side, 35 plus 27, 35 plus 27, 45, 55, 62 over 9. And what we have shown that if I put 14 over 3 in for the x values, that both sides are 62 over 9. Both sides. And what that means is 14 over 3 is the value of x that will make this side equal to this side. And solving the equation means we have the answer that works. That's a lot. Okay, sorry, the last video was really long because that's a lot. I'd encourage you, if you didn't follow this one, because this is as complicated as it can get with all the fractions. Okay, most of them are actually easier. But if you didn't follow this one, go back and work through the steps again to make sure it makes sense for you. Okay. So the bad news is, long video, you might have to look at it again. The good news is, it's the last video for week 6. Have yourself a great week 6, and we will talk to you next week.